Okay, so we are at section R.5, and here we'll be talking about basic equation solving. Now, so equation, okay, this is an expression. So here we have an equation where we have the two expression and they are equals to each other. For example, if we have, okay, so you have the equation, so it's a statement and you can find the two expression equals to each other. For example, if we have 2x plus 4 equals to 5. So here we have the two expression. So 2x plus 4, so this is one expression, okay, and 5. This is the other, and these two are equals to each other. And this is our equation, okay. The very easiest way to know the equation is if you have an equal to sign, then that is the equation. Now, what does it mean by solving an equation? So here we have an equation 2x plus 4 equals to 5. What does it mean? So what is x here? X is the variable, right? 5 is the constant. What do we call 2? What do we call this here? What is this 2? Right, it's a coefficient, right? Now what does it mean by finding, or what does it mean by solving this equation? What are we trying to find here? Okay. Now can your x be any number here? Can we choose x equals to 0 for this equation? So what happens if we choose x equals to 0? Will our equation be a true? Let's try that, okay? So if you want to see whether 0 is the solution for this equation or not, we substitute 0 for x. And if we substitute 0 for x, we get 2 times 0 plus 4 equals to 5. We get 4 equals to 5. And that is not true, right? So 0 is not a solution for this equation. So solving the equation means we are looking for the value of variable that make our given equation true. Now for what x value this equation is true? Can you give me a number? 1/2. Okay, let's try that. So 2 times 1/2, that is 1. 1 plus 4, that is 5. 5 equals to 5, true. So 1/2 is the solution for this equation. So every time if you are asked to solve the equation, you are looking for the value for the variable, okay, that makes the equation true. Okay. Now, so the next here, if we have an equation, okay, if our equation is of this form, ax plus b equals to 0, then our equation is linear equation. So you have an equation, okay, and the equation is of this form, ax plus b equals to 0. A, b, it can be any real numbers, and a is not equals to 0. If you have the equation ax plus b, that is your linear equation, okay. Quadratic equation, we'll be talking a lot about linear equation, quadratic equation, okay. It's just a kind of a review here. So quadratic equation, if you have an equation of this form, ax squared plus bx plus c equals to 0, then your equation is quadratic equation, and here a, b, c are real numbers and a not equals to 0. Now if we compare these two equations, what difference do you find? Like if you compare linear equation and quadratic equation, what difference do we find here? What difference do you see in the solution of each equation? So you have a linear equation and you find the solution. You have a quadratic equation and you find the solution. What difference do we find in the solution, in the number of solutions?
One is a binomial and the other one is a trinomial.
Okay.
There are two solutions to a quadratic equation. One solution to a linear equation.
That's right. So if we are talking about linear equation, then the linear equation has only one solution. Like the very first example, 2x plus 4 equals to 5. This is our linear equation. And if we solve this equation, we only had one solution, 1/2, right? But if we have a quadratic equation, then we get two solutions. Two solutions can be the same or different, okay? If you have a quadratic equation, if you are solving quadratic equation, make sure you have two solutions for that quadratic equation, okay? Now there are different principles to solve the equation, okay? The addition principle is that So if we have a equals to b, so we have a two expression equals to each other, then you can always add same number on a both side of the equation, right? So you can always add c on a both side of the equation, and you end up getting equivalent equation. You have a equation, and you can always add a same number, or you can always subtract a same number on a both side. Okay. And similarly, if you have two expression equals to each other, then you can always multiply the equation by a same number, okay, or you can divide both sides of the equation by a same number. That's also true. Okay. Now here, if you have the product of two number equals to 0, let's say we have a two different number a, b, and the product of these two number is equals to 0. What can we say about a and b? You have a two different number and their product is equals to 0. What does that mean?
One's probably gonna be 0.
One has to be 0, like at least one has to be 0, right? You have a two number and their product is 0, that at least one number has to be 0. So both can be 0, okay? So if you have a times b equals to 0, then a has to be equals to 0 or b has to be 0. At least one number has to be a 0 in order to get a product of two number equals to 0. This is the one that we will be using to solve the equation, okay? And the next, if we have x square equals to some number, let's say k, some positive number k, then we get the two equation for x. So x is square root of k or x is negative square root of same number k, okay? Now let's use this principle to solve an equation here. So we have an equation 3x square minus 6 equals to 0. Now what kind of equation is this? Is this the linear or quadratic? Okay, how do we know? You can check the degree, okay? If the degree is 1, that is the linear. If the degree is 2, that is the quadratic. Now the degree of this term is 2, right? So the degree of 3x square term, so the degree is 2, the degree of constant is 0. The highest degree of a term is the degree for the given equation. So 2 is the degree, it means it is a quadratic. Now let's solve this equation. So this is our quadratic equation, okay? So solving means you are making your variable alone by itself in one side, okay? You can make your variable alone in right side or left side, it does not matter. So what would be the first step of solving this equation? Okay, we can add 6, that is our addition principle. So we can add 6 on a both side of this equation, okay? We can add 6 on a both side of this equation. This is our addition principle. And let's see what happens. After we add 6 on a both side, we have 3x squared, okay? Now negative 6, positive 6, it is 0, right? Or cancel, equals 0 plus 6 is a 6. Now what will be the next method? We are trying to make our x alone, and this x has a 3 in the front and it has exponent 2. So
Divided by 3.
okay, we divide both sides by 3. We can divide both sides of the equation by a same number. This is our multiplication principle. So 3x squared divided by 3, that is x squared, equals 6 divided by 3, that is 2. Now this is what we have. We have x squared equals to 2. Now x is not alone. X has exponent 2. We need to get rid of that 2. And we use our principle of square root. So we use our principle of square root. Okay. So if you have x squared equals to k, then x is square root of k or x is negative square root of k. So using square root principle, our x is, so we have x equals to positive square root of 2 or x is equals to negative square root of 2. So these two are the solution for this quadratic equation. Now how do we know this is correct? How do we check whether x equals to square root of 2 is a solution for this equation?
We can plug in the answer.
Okay, let's go back to our equation. Let's check this one. So our equation is 3x squared negative 6 equals to 0. Now you substitute your x in this, for every x in this equation. So we have 3 times square root of 2 square minus 6 equals to 0. We have 3. What is the square of square root of 2? So we can cancel this. So this is square and this square root cancel, right? It's going to be 2. We'll talk detail about the rational radical expression as well. So this is 2 minus 6 equals to 0. 3 times 2, 6. 6 minus 6 is a 0 equals to 0. And this is true, right? So if you have a 2, it means x equals to square root of 2 is the solution for this equation. And you can similarly check for negative root 2. So this is these two are the solution for this quadratic equation. Okay. Now the next R.6. Okay. So here we have the rational expression. Okay. How do we define the rational number? It's pretty similar with the rational expression. So if you have any number, okay, if you have any number of the type p over q, so you have a number, okay, and your number is p over q, and q is not equals to 0. These are the rational number, right? This is what we did on a very first day. Okay. Now it's similar. If you have, okay, so let's say your polynomial, you have p of x divided by q of x, and q of x not equals to 0. So you have if you have the expression of this type, okay, if you have the expression of this type, p of x over q of x, then your expression is rational expression. So we have here an example. If you compare this expression 2 over x minus 3 with our definition for p of x, what do we have? If you compare this example and the definition, for p of x we have 2, right? So our p of x is 2. So this is your p of x, and q of x is x minus 3. So p of x over q of x, this is our rational expression. Okay. Now here in this example, you are asked to find the domain of this expression. What does it mean by the domain? Okay. Now when you are asked to find the domain, now we are looking for a number, okay, for which this expression is undefined. Okay. Can you give me a number? It can be any real number for which this expression is not like defined.
It's quadratic for 3.
Okay, what happens if this expression, if our x is equals to 3? Let's see. Okay, if x is equals to 3, okay, let's try for x equals to 3. So our expression is 2 over 3 minus 3, and this is 2 over 0. So what is 2 divided by 0? It's undefined. Okay. So when you choose your x to be 3, we have undefined. Now what about if we choose x equals to 0? What happens if x is equals to 0? So we get 2 divided 0 minus 3, and that is we get negative 2 over 3. We get some real number, right? So this is our real number. Now is there any number for which this expression is undefined other than 3? Can we find any other number, okay, for which this expression is undefined, like when x is equals to 3? Now if you choose any real number other than 3, this expression is always true. You choose a number, any number, but other than 3, you can always find some value. Okay, you can always get the real number. So every real number other than 3 is the domain for this expression. We'll be talking in detail. Okay, so right now, for now, the domain is all real number other than 3. So all real numbers, so every real numbers other than 3 is the domain for this expression. Domain are the number that makes the given expression defined. Okay, but we'll be talking a lot about the function, domain, range, okay, everything. So this is just an example. Okay, now here, now is this our rational expression? What do you think? Is this the rational expression? to be a rational expression, we must have p of x over q of x. You must have the numerator and denominator. If it's a fraction, it's a rational expression, the easiest way. Okay, so this is the rational expression, and we need to simplify. So here, in order to simplify, what we do is that we factorize our numerator, we factorize our denominator. Again, we look for the common factor in numerator and denominator. Now we have our numerator. Let's do this separately. So our numerator is 9x squared plus 6x minus 3. Now let's factorize this. If you are asked to factorize rational expression, if you are asked to simplify the rational expression, then we have to factorize numerator and denominator. Now how do we factorize this? So what is the very first step of factorization? What do we look for? Yes, we look for is there a common factor in each term or not? Do we have a common factor in every term? Okay, what is that common factor? 3, right? Okay, now let's factor out 3. Now if we factor out 3 from 9x squared, what do we have? Okay, so if we factor out 3 from 9x squared, we have 3x squared. Okay, if we factor out 3 from 6x, what do we have? We have 2x. And if we factor out 3 from negative 3, we have negative 1, right? Okay. Now is it completely factorized? Can we factorize any more? What kind of expression is this? Is this binomial, trinomial, or monomial? It's a trinomial, right? And now is this trinomial of this type? So in our previous class, we talked about the factorization. Now if we go back, so here, so our trinomial is pretty similar to this one, ax squared plus bx plus c. Okay, if your trinomial is of this type, then we use the AC method. So let's try to use AC method for this trinomial. Okay, so in the AC method we find AC first. Okay, Michael. Is here Michael? Okay, in this, what is A and what is C here? Can you tell me what is A equals to and what is C equals to? Okay, what about C? Okay, A is the coefficient of square term. Okay, so A is not the first term, A is the coefficient, A is the number in front of square term. Okay, so your A is 3 and C is negative 1. That's right. Okay, so A times C is 3 times negative 1 is negative 3. When you are doing AC method, you can ignore sign. So let me take 3 times 1, which is 3. Now we write down every pair of factor of 3. Okay, do we have, okay, Logan, can you give me one pair of factor for 3? Where is Logan? Okay.
3 and 1.
Okay, that's right. So do we have any more pair of factor for 3? It's the 1, right? Now we're going to use 3 and 1 to rewrite our positive 2x. Okay, how can we use 3 and 1 to rewrite positive 2x?
3 minus 1.
Okay, 3x minus 1x, that is positive 2x, right? So here, so we have 3 as it is, 3x squared, and we rewrite our 2x using this pair of factor. So 2x is same as 3x minus x and minus 1. Okay, we use this pair of factor to rewrite the middle term 2x. Now we have 4 terms. So we make a pair. So make a pair of first 2 terms and last 2 terms. So we have 3. Now in the first 2 terms, do we have any common factor? What is the common factor in first 2 terms? 3x. So let's factor out 3x. And once you factor out 3x from 3x squared, we have x. And once you factor out 3x from positive 3x, we have positive 1. Okay, in the last two terms, what is the common factor? Negative 1. We factor out negative 1 from last two terms. Once you factor out negative 1 from negative x, that is positive x. And once you factor out negative 1 from negative 1, we get positive 1. Okay, now we again have a common factor, x plus 1. X plus 1 is the common factor. So we have 3 times x plus 1. You factor out, then we have the remaining 3x minus 1. So this is the complete factor for our numerator. So here we have 3 times x plus 1 times 3x minus 1. So this is the factor of our numerator. Now in the denominator, so 12 is the common factor. So let's factor out 12. So we have x squared minus 1. Okay. Now can we factorize our denominator, or so we have x squared minus 1, that is a difference of square. And if we have a difference of square, then this is what we're going to use. So if you have a difference of square, then that is your a plus b times a minus b. We're going to use this one. Okay, so you can rewrite 1 as a 1 square. So let me rewrite numerator as it is, divided 12. Now x squared minus 1, or you can use a FOIL, still the same thing. Okay, so if our first term has to be a x, right? To get x squared, our first term has to be x. Now what are the two numbers whose product is negative 1 and sum is equals to 0? There is no middle x term, so sum has to be equals to 0. Give me a two number whose product is negative 1 and sum is equals to 0. Negative 1 and positive 1, right? Negative 1 times positive 1. Negative 1 plus 1, that is 0. So negative 1, positive 1. So if you are asked to simplify the rational expression, you factorize completely numerator and denominator. Then we look for the common factor in the numerator and denominator. And if we have a common factor, we can cancel that. So what is the common factor here? Okay, x plus 1 is the common factor, so you can cancel. And we can divide 3, we can simplify 3 over 12, right? So 3 times 1 is 3 and 3 times 4 is 12. Okay, the remaining is 1 times 3x minus 1, that is 3x minus 1 divided 4 times x minus 1. And this is our final expression. This is the simplified version of our given rational expression. Okay, let's see what we have next here. Okay, now we have addition, subtraction of the rational expression. Okay, before this one, let's take a simple example. So we have, let's do 5 over 12 plus 4 over 48. How do we add these two different fractions? So if we are adding these two different fractions, how do we add these two fractions? Right, we need to have a common denominator, right? Now, what is the common denominator? So the first expression has a denominator 12, the second has a 48. Now, what is the common? How do we know that? So how do we find the common denominator of 12 and 48?
It's the greatest common factor.
Okay, now let's see. So if you want to find the common factor, now, so for this one, 48 is correct, okay? But if you want to find the common factor, now we take each denominator. So we have these two denominator, okay? And we express each denominator as a prime factor. Now how do we find the prime factor of 12? Okay, what does it mean by prime? Have you heard of prime number? Can you give me an example of prime number? Is it 1 is a prime number? What is the smallest prime number? It's 2. So your 1 is not the prime number. 3, yes, 3 is a prime number. What about 7? Is 7 prime number? What about 9? Okay, prime number is a number, okay, that we can divide by itself and 1. So if you have a number and you can divide that number by itself or 1, then those are prime. Okay, like 23. We can divide 23 by 1 and 23 itself, right? There is no any other number which divide 23. Okay, so now for 12, we're gonna list every factor, every prime factors. Okay, so in order to find the prime factor of 12, we're gonna use the tree diagram. I'm pretty sure you all have done this one. So we have 12. So the smallest prime number is 2. So we choose 2. So 2 divided by 12 is 6, right? Now for the 6, we can rewrite 6 as a 2 times 3. So 12 is same as 2 times 2 times 3. So you write down your denominator as a prime factor. 2 times 2 times 3. So your every factor has to be a prime number. Okay. So here 2 and 3 all are prime factor. Now in the similar way, how can we rewrite 48 as a prime factor? So okay, so let's do here. We have 48. So what is the smallest prime number that divides 48? That's 2, right? 2 divided 48 is 24. 24 is not a prime number, so we have to rewrite this. So the smallest number that divides 24 is 2. So we have 12. 12 is not a prime number, so we have a small number 2 that divides 12 by 6. And we have 2, 3. So our 48 is 2 times 2 times 2 times 2 times 3. So you write down each denominator as a factor form, prime factor form. Okay. I need to erase this part here. Can I erase a tree diagram for 48? Okay. So make sure when you are looking for the least common denominator, you have to have your denominator as a factor form. Okay. Now your common denominator. Okay. So let me just write CD for common denominator. Okay. It's the same as finding the least common multiples. Okay. So you have heard, you know, the LCM, right? The least common multiples. So it's the same as the common denominator. Now what you do is here is that, so at first we take the factor which is common in both numerator. So what is the factor which is common in both denominator? So this 2 and 2 is common, right? So if you have a common, then you are writing 1 time. Okay. In the common denominator, once you have the factor for each denominator, you write down the common factor once. Okay. Now do we have any more common? So 2 is common, right? So for this common, we write down once. What is the next? The next common factor is 3. So this is, you write down once. So at first write down every common factor once, then write down the remaining factors. Now what are remaining? We have 2 times 2 remaining. So 2 times 2. And if you multiply all these, 2 times 2, 4, times 3, 12, times 24, times 2, that is 48. And you get your common denominator. You write down each denominator in a factor form. Okay. Then write down the common factor once and the remaining factor as it is. So these two here, these two are not common, so we just copy here. Okay. And these 3 are common on both denominator. Okay, now once we have the common denominator, okay, so let me rewrite our expression. So once we have the common denominator, we need to make denominator of each expression equals to common denominator. Now, how do we make 12 equals to 48? Multiply by? Now, where do we multiply? In the denominator or in the numerator? Both. Yes. So we multiply numerator and denominator of this expression by 4. And the reason is we need to have 48 in the denominator. For the second expression, the denominator is already 48, right? So no need to multiply. So this is 4 times 5, 20 divided 48 plus 4 divided 48. Now we have the common denominator. And if we have a common denominator, we can add numerator, right? Yes.
Wouldn't it be easier to make the 4 over 48 1 over 12?
Okay, one more time.
Like make them the bases both 12 instead of both 48. Wouldn't it be more simple?
Oh, okay. Yes, you can do. So you can, so that's the other way. So, okay, as per him, so if you simplify this expression by itself, then you get 1 over 12, right? And if you have 1 over 12 and 5 over 12, you don't need to do this middle part. Okay, that's the other way. Now, for this case, we didn't do that one. Okay, so here, since we have the common denominator, so we have 20 plus 4 divided 48. 20 plus 4, that is 24 divided 48. Okay. And we can simplify this. 24 times 1 is 24. Okay. So if you divide numerator and denominator by 24, we get 1 over 2. So 1 over 2, 1/2 is the final answer. So here, I want you to know how to find this common denominator. Okay. You have done this a lot in your middle school, high school. Okay. So whenever you are looking for the common denominator, write down your denominator in a factor form. Okay. Then you collect every factor which are common and which are not common. You multiply all together, you get the common denominator. Okay. Now here, so we have the algebraic expression. Now how do we find the common denominator? The process is same. Okay. The method is same here. Okay. So we have this expression and we need to find the common denominator. So let me get rid of this here. Okay. So what we do here is that we write down our denominator in a factor form. Now let's write down our denominator in a factor form. So our denominator are 2x squared negative 3x plus 1, right? And the other one is 2x minus 2. 2x minus 2. Let's write down each of these in a factor form. Now how do we factorize 2x squared minus 3x plus 1? What method do we use? The coefficient of square term is not 1, so we use the AC. Okay. So here, so in AC method, we multiply AC, right? So our A is 2, C is 1. 2 times 1 is 2. You multiply A and C. Then we write down every pair of factor of 2. So we have only 1. 1, 2 is the only pair. Now we use this pair of factor to rewrite negative 3x. Now how can we rewrite negative 3x using 1 and 2 as a coefficient of x? So what is negative 3x equals to using 1 and 2? Negative 3x is minus 2x minus x, right? So we have 2x squared, and for 3x you are using this 2 and this 1. So 2x minus x and plus 1. We have 4 terms. Let's make a pair. So in the first 2 term, our 2x is common. So you factor out 2x. Once you factor out 2x from 2x squared, so you have x. And once you factor out 2x from negative 2x you get negative 1. You are dividing each expression by common factor, okay, to get x minus 1. So if you divide 2x square by 2x, you get x. If you divide negative 2x by 2x, you get negative 1, okay. Now in the last two term, negative 1 is the common factor. So negative x divided by negative 1, that is positive x. Positive 1 divided by the common factor, negative 1 is negative 1. Okay, you are dividing each term by the common factor. So we have x minus 1 common. So let's factor out x minus 1. Then the remaining is we have 2x remaining and minus 1 remaining. So this is the factor for this trinomial. 2x squared minus 3x plus 1. And the next denominator is 2x minus 2. So this is easy one. We have 2 as a common factor, and 2x divided by 2 is x. Negative 2 divided by 2 is negative 1. Our target is finding the common denominator. The first step, you write down your denominator as a factor form. Now we look for the common factor. Do we have any common factor? So what is the common factor here?
X minus 1.
Okay, now before that, now is 2 common factor or not? What about 2? 2 is a factor for this second denominator, but is 2 factor for this first expression? Factor form means it has to be in a product form. Do we have 2 times and the expression? So here for this one, your factor is x minus 1 and 2x minus 1. You can't take coefficients individually, okay? Having in a factorial form is it has to be in a product form. See, so this expression and this expression, in between these two expressions we have a product here, and that is why these two are the factor, okay? In this one you have a 2 times x minus 1, so these two are the factor, okay? Now here, now the common factor, our common factor is x minus 1 is common, okay? So let's write down this once. So you write down the common only once. Now do we have any more common? So you have x minus 1 as a common. Now do we have any common factor? 2 is not a factor. 2 is a factor for this one, but 2 is not a factor for the first one. So it's not common. Now there is no common, so we rewrite the remaining the remaining factors, okay? So we write down every remaining factor. So this is remaining, so you have 2x minus 1. This is remaining, so you write down 2. And this is the common denominator for these two denominators. So this is the common. Now our target is making denominator of each expression same as the common denominator, okay? The remaining we will do when we have this addition or subtraction, okay? It's going to be a lot, okay? So right now let's do one more finding a common denominator, okay? Simplification we will do when we start the chapter, okay? We'll do this one as well, okay? So here let me take an example. Okay, let me go back here. Okay, can you find the common denominator for these two expression? Okay, this is for you. So I'll give you 2 minutes. You can do in a group. So find the common denominator for x squared minus 9. So this is the one, okay? Then the next, okay, the next one is x squared negative 6x plus 9. Okay, find the, you can just call it LCM, or when we are talking about the rational expression, it will be is a common denominator. Okay, find the least common multiple for these two. Same method. At first you express each expression in a factor form. That is your first step. Okay, so you have x square minus 9, so you factorize x square minus 9. Then you have x square minus 6x plus 9. You factorize x square minus 6x plus 9. And once you factorize, you look for the, you collect the like factor to, you collect the common factor and the remaining factor. If you multiply all those, you get the least common multiples. What are the factors of for x square minus 9? What method do we use to factorize this? Can we use the FOIL? We can. What about the other? So if we have a this is the difference of perfect square, right? So as I said earlier, so if you have a difference of square, then your factor is sum of those two terms times the difference. Now here x square minus 9 we can rewrite as a x square minus 9 is a 3 square, right? So this is your a, x is the a and 3 is the b. Now you substitute a b in this factor, so you get x plus 3 times x minus 3. So this is the x plus 3 x minus 3 is the factor. Now for the next one we have x square negative 6x plus 9. So what method do we use to factorize this? This is a trinomial and this is a quadratic form, and the coefficient of square term is 1. We use FOIL. Okay, so in the FOIL we have a 2 factor. So what should be the first term so that we get x square when multiplied? X, right? Okay, x. Now let's find a 2 number whose product is 9 and sum is negative 6. Give me a 2 number whose product is positive 9, sum is negative 6. Negative 3, right? Negative 3 times negative 3, positive 9, negative 3 plus negative 3, that is negative 6. So your 2 number are x minus 3 and minus 3. So we have these two factor, x minus 3, x minus 3. Now once you have the factor for each expression, we look for the common. So for least common multiples, so do we have any factor common here? So you are comparing these two. Okay, we are looking for the common. Do we have any common factor? X minus 3. Okay, so this x minus 3 and x minus 3 is common, so you write down once x minus 3. Now do we have anything common? No, right? So you write down every remaining factor. So you have x plus 3 from first, x plus 3, and x minus 3 from the second, x minus 3. Write down the common first, you write down once, and the remaining factor as it is. You copy every remaining factor. Okay, so here this factor is, we write down as it is, x plus 3, right? And x minus 3 as it is, x minus 3 as it is. This is how we can find the least common multiples. Okay, the simplification, we'll just keep this. Okay, it's gonna be a lot, so we'll do in like when we are talking about the rational expression, we'll be doing all this. Okay, the next here we have a complex rational expression. Now at first, why this is called complex expression here? So here in the numerator and denominator we have a fraction. So if you have a numerator, so in your numerator and denominator, if you have a fraction, that's a complex. So this is your numerator. So this is the numerator, okay? And this is the denominator. In the numerator and denominator we have the fraction, and that's the complex, okay? If you have a rational expression or if you have a fraction in the numerator and denominator, that make the expression complex, okay? And here we need to simplify, okay? Let's keep simplifying for a while, but before simplifying we need to know how to find the common denominator. So let's take this numerator first. So in this numerator, can we add 1 over a and 1 over b? We need to add, we need to have a common denominator, right? So can you just find the common denominator for a and b? What is the common denominator when you have ab as, when you have this denominator? ab. And the method is same, okay? So the factor for a is a itself, right? Factors means a number that divide. For factors of b is b itself. In order to find the common denominator, we look for the common factor. There is no common factor, so you write down every factor together. So you have a, b. So this is the common denominator, okay? Now let's take the denominator. So here we have a cube and b cube. Let's find the common denominator for a cube and b cube. So what is the common denominator for a cube and b cube? Okay, now here let's factorize. A cube is same as a time a, right? B cube is same as b time b. Now for the common denominator, do we have a common factor? No. So if we don't have any common, we just write down all factor together. So you write down all of these together. So you have a time a time b time b, and you end up getting a cube b cube. This is the common denominator. If you can do all this on your head, you don't need to do it on a side, okay? Okay. So, do you have any question? So, don't worry, okay? We will be doing all these things throughout the semester, so you don't need to worry. If you don't know, just ask me, let me know, okay? But if it's taking time for you to learn the things, you don't need to worry, okay? We'll be doing all of these things together, okay? So let's do this much, and your okay. The homework, yes, you can always find the homework on a canvas, okay?